everybody to our session today with myself, Mary Grigleski, and with Grace. Just a quick note too, Grace and I, I used to work at IBM, so that's how we kind of get together again and then present this session. And as such too, we'll give you a bit of an extra thing too, so we'll reveal to you shortly. But the thing is too, today's session is exploring stateful microservices in the cloud-native world. So as such, right, as you can see, we're going to talk about, well, actually, first and foremost, MicroProfile, Open Liberty, and then I also add in some information about Apache Pulsar too. I don't know if some of you have worked with it, so I think it would be interesting from a cloud-native platform, messaging type of platform. So yeah, so that's our talk today, but let's first go over some introduction too. So I have Grace here with me. Let me click, and then Grace will introduce.
We're going to have to do the awkward slide and shuffle in between for our mics, so excuse the weird sort of dancing on stage. So yeah, hi, my name is Grace Jansen. As you can see, I'm a developer advocate at IBM, as the top suggests. I focus primarily on Java, cloud-native technologies, MicroProfile, open source, reactive, all that good stuff. I'm actually originally a biologist turned software engineer. You might see my other session later today where I talk a bit more about the biology side of things. But switched over to the dark side with Dev. So I'm also passionate about encouraging more women in technology, so it's great to see some of the women from the breakfast this morning. Hello. I love traveling and trying new activities. So that's me. Thanks for coming along.
Thank you, Grace. So yes, again, my name is Mary Grigleski. I'm currently a developer. I'm sorry. Okay, sorry. Yeah, so I'm currently a senior developer advocate in the streaming product at DataStax. So if you're familiar, DataStax is the company that has managed Cassandra. So we're all about open source too. So I'd like to also share some of the information with you from a cloud-native, like stateful type of perspective today. So I'm, I was with IBM for 3.5 years before, being at DataStax, also as a Java developer advocate there. Then I myself too have 25 years or so of experience being a software engineer involved with development, design, all that good stuff. And I'm sure a lot of you in the audience are coming from the IT, you're supporting your business. So I'm really familiar with that. I can understand the pain and the joy. So what else? I'm also the president of the Chicago Java Users Group. So I'm also active with the community too. So yeah, so that's kind of about myself. So with that, we can start this session. So.
Cool. So we're going to start with some basic concepts, just covering sort of what is the difference between stateless and stateful? Why are we doing this presentation about running stateful microservices on cloud native? So we're going to use a cartoon for that. I'm hoping you guys have seen Finding Nemo. Yeah, I'm getting nods in the crowd. Excellent. Hands up, hands up. So for anyone who might not be sort of into the world of Disney, maybe you haven't seen it, maybe you just don't enjoy cartoons. There is a cartoon fish. It's a little fish called Nemo. He ends up getting lost in the ocean. His dad goes to find him, the big orange fish in this picture, and he bumps into someone called Dory. Now, Dory is a very forgetful fish. Dory likes to just go about doing anything sort of in the moment. He doesn't really have a very good memory. Whereas Marlin, on the other hand, the dad, Marlin is a very cautious guy. He likes to think things through before he acts. He has a very good memory and remembers things a little too well. So Marlin tends not to take opportunities that Dory takes full advantage of. So in this scenario, Dory, in her sort of forgetful state, really is sort of representing stateless. Dory doesn't really have any inbuilt memory. She isn't able to recall events that have happened in the past. She just sort of is happy-go-lucky. She's quite agile in the way that she responds to events, whereas Marlin, on the other hand, he sort of has to remember things before he jumps into things. He has to think back to those events, recall the memories, so he's a bit slower and he tends to represent more of a stateful application. So we're going to be using this analogy throughout as we go through this presentation of Dory and Marlin, so keep that in mind as we go through. So looking back, computing life used to be a lot simpler. So when we first started out with computing, actually everything tended to be stateless anyway. So we used to have way more stateless computing. And what do I mean by stateless computing? Well, it's really all about having this sort of communication protocol that means that you don't retain any session information. So the state of the data doesn't actually get recorded between transactions. So a good example of this in everyday life, for example, would be, let's say you're doing a search online, you've thought of a question and you want to answer it. In that case, if your browser was to crash, it doesn't really remember that, you just log back in and search again. So in that case, it's more of a sort of, you can kind of think of it like a vending machine. You've got a single response and a single request. And if you need to do it again, let's say your Coke didn't come out of the vending machine, well, I'm sorry, you've got to put £1 in again, or $1 in this case. So that's more about stateless computing. And with this kind of computing, as a result of this, the architecture, the design, and the implementation tends to be simpler. So if you're trying to scale the system, for example, that tends to be easier because you can just spin off a component without having to worry too much about sort of initializing it into a certain state. And recoverability from system failure tends to be easier as well. However, realistically, we live in a stateful world. Now let's take an example where it might be your spouse's birthday, and if you haven't remembered that, there can be all sorts of consequences that come along with that. So realistically, we live in a society where we are expected to have this memory. Dory is expected to remember her past. We're expected to remember anniversaries, birthdays, etc. So actually, it's more likely that we're going to be designing our applications to reflect this reality, to reflect the fact that actually, in a lot of cases, we need state within our applications and we need state within our microservices. And this is where stateful computing can come into play.
All right, I think you should be able to hear me. I think our microphone is working, but I'll still keep it in here. So yes, so then switch to talking about stateful computing. Actually, let me ask you, how many of you are kind of also heavily involved with working with data of some sort, right? You're processing data. Yeah, I guess it is actually, that's what actually gives meaning to what we do day to day. We're not only doing computing, but we're doing the data part, right? That's kind of the bulk of the, what you have to deal with. So, but of course, computing gives it the brain over the data is what it is. So for stateful computing, as Grace explained, for the the non-stateful, right? It's completely opposite, right? For stateful, then we would make sure that when you make any requests, the request gets sent probably with some context that you have from before, some kind of memory things, right? That's whatever it is, right? It's some kind of context you need to carry with it. And then as a result too, it will cost time for you to process that if you want to include like stateful data with your processing. However, as such, right, it is very important. We do need to handle this kind of situation, but it, whatever it is, it's going to make your computing more complicated, but it is necessary. And then likewise, too, if you are talking about scalability, resiliency, all these are very important, especially in an enterprise computing environment. That's also is going to make things a lot more complicated. If you want to scale, how do you do it, right? When you need, like in a cluster, you have certain, let's say even like pops up kind of scenario topics, the broker, right? You have it like deployed in multiple cluster. So if you need to scale it up and down, then you want to make sure your topic too is kind of, even if it's partitioned off, everything kind of get rebalanced correctly. That part you need to take care of it. It's more complicated, no doubt about it, right? It will cost that to happen in your computing infrastructure. So that's stateful in a nutshell. But then also kind of step back a little bit. As such, all of you have worked with data. It seems funny, when I first started as a software engineer, it was kind of back in the old days, well, kind of 90s. And people were more about computing. The Linux were up and starting to do Java. People seem to pay more attention to the computing side and not pay so much attention to the data. But as such, too, as I'm learning, too, data is so important. And we want to also understand, right, stateful data. So the state of data, we kind of examine it. Now, we learn, right, as programmers, we deal with data. There's structured data and unstructured data, data types that are primitive. You deal with primitive data types, Java, right, int, integer, string, all of these things. But the thing is, too, there's also the states of data that we need to worry about that complicate things a lot. And essentially, too, there are three, we can break it down into like three fundamental states of data. So first and foremost is data at rest, right? At rest, it's more like when data kind of lives on like some kind of persistent storage that's at rest. It could also be actually in memory as well. It's just resting, not doing anything. And then there's also data in motion, is when it's kind of in in transit, right? Doing like network kind of communication, all of these things, it kind of goes over the wire. Doing a pub-sub, kind of a publish-subscribe type of scenario. So they are in motion, kind of like constantly changing to the state, and we need to capture it. And then there's also data in use. So in use is more like in the phase of you doing analysis. Maybe you already fetched the data from your database or some storage, and then you have to like operate on it, so to speak, they're operating on this data. So if you take a look, right, the role of microservices for the data is really, microservices is a place, or at least this is how I kind of visualize this, is a place where we operate on the data. There are lots of like read and write, right? There's fetch from your database or some data source, or place it into, after you're done processing, you write it back to the data source. And then the data source can be disk, in-memory thing, or cloud, and then also there could be like network. It can be comes in a socket, or like pub-sub type of scenario, and messaging kind of can come as a source, like you publish your data and as a source. And essentially too, where the input-output gets triggered is where your microservices is, right? It gives it the place where the data gets triggered to things to happen. And then also, that's the place where transformation and any remediation needs to happen too, is in the microservices side. So that's how we kind of set up the stage at this point. So, okay, but first, let's kind of take a look too. I think would be interesting to look at some history, right, about statefulness, right, in the cloudless days. Before the cloud comes in, it's actually life was simpler. It's not really that simple, still complicated in its own ways, but the thing is, without the cloud, all of these extra things to worry about. So what are the mechanisms, right? So let's take a look into that. So first of all, back in, before the cloud days was client server type of systems, right? When Java came out, it was first Java, and then we quickly realized we need to handle data and all of these things. And so that's when also client server systems comes in the I guess late 90s, early 2000, and all the processing. And essentially too, even before Java, there's also stateful database systems. And basically, it's on the server side, right? So we're kind of relying on the database to help us too. Every time when we deal with data, we also bring in the transactional aspect, right? We need to read and write and do updates and all of these things. So at the same time too, as we know, a lot of the relational database, they all have transactional support. So we rely on database transaction to help us to preserve state, things like that. And then also, interestingly, wanting to bring up too, then, in a simple case in which you can have like, one system or like a complex system, but you are usually in the old days, monolith days. We're relying on maybe one database to keep all the data from everywhere. And it in some ways is simple enough. You don't need to worry about the data in motion, kind of travel across maybe to different place in the network. So in that case, then it's simpler. But the thing is too, you actually could have multiple instances of the database operating at the same time. And they not only that, you can have maybe different flavors of Oracle running in your enterprise, a different version of it. And then, of course, you can also have multiple vendors that are running these databases, that they all participate in a single transaction. And I think a simple case, or not that simple, is basically a typical example to cite would be like an order entry e-commerce type of systems that you can have operating your orders, taking your orders, everything, and then the order travels through many kind of stages, right? You have to check your inventory systems, you have to check and make sure the customer has money, has the funding to pay for it, and then you need to pay all these things, right? So all those things, basically, it complicates things. So what used to be, too, for managing state in a complex environment like that would be a protocol. It's called two-phase commit, or 2PC. Maybe some of you have worked with it. So 2PC, too, the thing is that it definitely works, but it's a very slower process, but it's kind of guaranteeing your transaction, but it's definitely slower because it's synchronous in nature. So if you have any requests, let's say your enterprise, you have multiple copies of your database 1, 2, 3, and then you'd be doing something for your order processing. But in the meantime, too, you can have another system also handling your whole order system that's traveling through your whole transaction space. But what if something goes wrong, right? So that's when the two-phase commit comes in, because it's like the coordinator. It coordinates all of the transactions that are happening in all your systems that are running in time and space, so to speak. And so, you're relying on the two-phase commit, but the protocol, the way it works is that it relies on a two-phase or a coordinator, so like middle person kind of doing the thing. So for example, like I'm a two-phase commit coordinator. I might say, okay, I'm processing this, and let me make sure database one, are you done? Are you good with your transaction that you are inserting some data or updating? When you're done, tell me when you're done. I'll collect your votes. You are all good, then I collect your vote, it's good. Then I go to database two and ask the same questions. You're doing some other things in your processing. Are you all done? If you're good, give me your vote. If you're good, then I collect all of these votes. If everything is good, then I tell everybody to commit and then or roll back. But what if, right, the network isn't reliable? Something goes down. Then what happens is that this coordinator will be keeping everybody waiting. And that's the kind of protocol we used to have to deal with more. It's actually still being in use, but it's slower in that sense because, again, the blocking nature of this protocol. So as such, now with the cloud native and everything, there's a need to kind of come up with newer ways of handling this type of multi-transaction scenario that happens in an enterprise, especially a big kind of application ecosystem. So that's what it is. But that's what it happens in the old days. And then there's also back to this about some history, right, about stateful. So in Java too, I'm assuming a lot of you are Java developers. So on Java side, like with Java used to be Java 2 Enterprise Editions, or now Jakarta EE. So there's EJB that handles, right? And there's also EJB, I think used to be session EJB or entity database. So these are kind of mechanism within Java that helps you to persist data and maintain state, right? And there's also the stateless beans or stateful beans and then stateful session beans and all of these things. So that's Java. And then of course, if you're handling like web application, then there's HTTP session that actually helps you handle, because HTTP by nature, it is a stateless protocol. But it's also very synchronous. You issue a request, you have to wait for the response to come back, all of these things. So that's HTTP session, and that's how, like in Java, you can kind of leverage on that. Okay, and then how about then talking about client side? There's also, you can cache your server responses too. If you have requests going in, some context you want to kind of make sure it gets saved, between different requests by the same client, then you want to maybe do some sort of caching too. So that will be kind of ways that it handles, like stateful, maintaining stateful transaction within like a larger kind of, let's say, an application, a synchronization of events that happens within your transaction. So that's the background, right? So okay, so now then let's move on to today's world, cloud native, and we are in that environment now. And Grace can tell us more about the cloud native, some details too. So.
Yeah, so it's all about, okay, we've looked at how we were storing state previously. We've got all of these fantastic abilities that we were using, but now that we're in this cloud-native distributed environment, how do we translate those capabilities and those features into this cloud-native world? Thanks.
Oh, yeah.
So first let's examine this term of cloud-native, because you might be coming to this talk thinking, why are we talking about stateful microservices in cloud-native, when often the definition of cloud native by many companies is stateless? So actually, originally when we take a look at containers, they were originally built to be stateless because this really suited their nature in terms of portability, flexibility. However, our applications, as we've said, more realistically, come with state. So as more and more people started moving existing applications instead of greenfield applications into containers, we started to realize actually we need stateful applications within those containers running on the cloud. And so actually cloud native doesn't necessarily mean it has to be stateless. You can have stateful microservices that can work effectively within that cloud native environment. So if we go back to our Dory example, for example, Dory is that sort of stateless, agile, analogy that you can look at when we look at the original containers. However, Marlin still does pretty well in the ocean. Like, they're in the same ocean, they're both fish. Like, they still work effectively together, and so it doesn't necessarily mean you can't have stateful microservices. So actually, if we take a look at cloud native computing as a term instead of just cloud native, so cloud native computing is really essentially an extension to cloud computing, which sort of came out in the early 2010s. And this was originally coined as a term by Netflix. I'm hoping everybody's familiar with Netflix. If you're not, it is an extremely large, in fact, arguably the world's leading media streaming service. And as part of that media streaming service, as one of the pioneers in this space, they really looked at and developed this infrastructure of cloud native and leveraged the cloud really from the early days. So they were the ones who ended up coining this term. And when they coined it, they were really looking at three fundamental behaviors, three fundamental characteristics. And that's to be able to have highly available services, which I think we can all appreciate in media streaming, to be able to have scalable services. Look how much the media streaming industry has grown, how many people have adopted it, and to be performant. So to be able to perform no matter what load is on that system at that particular time. And it's these fundamental characteristics that we're all trying to achieve when we build cloud native applications. And actually, although some definitions, when you start looking online for cloud native, state, well, it must be stateless, you should be storing state in backing services, etc., etc. Actually, when you break down those individual definitions and take out all of the language-specific, platform-specific language within those definitions, you start to get a word map like this. So you start to see the same repeating characteristics and behaviors that relate to those original three. So all of these behaviors are what we're trying to achieve in cloud native, and that's what we should be driving towards rather than focusing necessarily on sort of, oh, well, it must be stateless. It's really about having microservices that are observable, that are scalable, loosely coupled, rapid deployment, all of these key characteristics. How do we achieve this? Because really, this is what we're all striving towards. Now, there's not necessarily a one-size-fits-all solution, but a methodology that I find quite helpful to take a look at is the 12-factor app methodology. So the good thing about this methodology is it's platform agnostic, language agnostic. Really, it can be applied to any application. This was originally developed by the developers over at Heroku, but it's now sort of been adopted by the community and expanded upon. So there's actually a 15-factor app methodology if you're interested in that. So really, this has been created as a set of guidelines or best practices to be able to achieve those characteristics and behaviors. And it works really well in terms of matching sort of the fact that we're building these microservices, that we want to have these behaviors, mapping it to, okay, how do we actually go about that in each stage of the development process? So if you've not seen it before, you can head over to 12factor.net, and there's a website that goes through each of these individually in a lot of detail. But here is an overview of the 12 factors. So as the name suggests, this methodology is based on 12 factors that if you follow, you should hopefully be able to create an application that can really thrive within that cloud environment. And this is really an overarching approach, so it doesn't necessarily dive deep into the specifics of each application, but is a really broad approach to, here are the various stages of development of how you're creating your application, and these are the bits and the behaviors that you should be thinking about. So it goes all the way from sort of code base, where you're looking at revision control, looking at your dependencies, how are you configuring your microservices, all the way through to sort of CI/CD pipelines, looking at continuous integration, continuous delivery, and going all the way through to processes as well. So here you can see the mention of stateless, and that sort of continues throughout with sort of, there we go, concurrency, so scaling out via the process model. And this is really more about focusing on horizontal scaling as opposed to vertical scaling. So where previously you might have had a really big monolithic application, and if you needed your application, let's say you've got a really big load one day, let's say it's Black Friday and you have a supermarket that needs loads of people are shopping for things. So if you have a bigger load on your system, previously, we'd have just sort of deployed more of that massive application and made it even bigger, which really didn't solve the problem where we had load on a particular part of our application, not the whole thing. So if you're able to adopt this sort of process model where we're breaking down our application into these microservices and we can scale those individual microservices, those individual processes, that way we can more accurately target that load, and so basically create more effective applications because you're making better use of that underlying cloud infrastructure. So you're not like creating more microservices where you don't need it because you don't have that load. So this can be a really useful methodology to follow when you're trying to create applications, And this can be the same methodology you follow for stateful applications as well. So as I said, it's pretty agnostic. And if you take a look in further detail at these, you can perhaps reflect on your own applications and see where you can improve it to be more effective in that cloud-native environment. So looking into the details of how we actually preserve state across session using some of these cloud-native technologies and open source projects.
Yeah, okay. Thanks. Thank you, Grace. So yes, so now let's kind of take a look, right? Some of the techniques that we can use in a cloud-native environment to do, this kind of preserving the state. So, I mean, as such too, we already kind of talk about like caching. So caching would be a way too that you can do, but you realize too, all of these things are essentially, right? And your microservices is still lightweight, but we are relying on some external capabilities to help us. You can have a cache. For example, I guess I can cite examples such as like Redis. You can use that cache, or MongoDB, or some kind of database to help you to do caching, and even Cassandra, you can do that too. And then there's also database style transactions that I already talked about. So you still can rely on database transaction to help you. But two, is at the same time though, it can get complicated if you're in a cloud native deploying things in multiple clusters. If you have multiple databases, then probably better off too, you can use a managed database as a service type of platform, such as Cassandra, right? Astra DB, right? So, okay, so that's that. And then there's also cookies. I mean, cookies we're very familiar, most of you are familiar with if you're especially working with web applications, you can leverage on cookies. But there's also, in Kubernetes too, also has concept of cookies too, that we can help to essentially keep the session data be valid during a transaction when it's still happening. Okay, and then there are also like other things like sessions and then tokens, all of these too. For example, like a login, especially cases in which you need to do some sort of security. You do want to maintain that token so then it's valid for that particular transaction. You don't need to require any request to re-log in every single time. So these are more techniques and mechanisms. And let's kind of take a look then into the cloud native infrastructure layer. And Kubernetes is everywhere now. So I'll use the example from Kubernetes as a container orchestrator. So in Kubernetes too, there's a capability called leader election. It's actually, leader election is actually quite important in any kind of cluster environment where you have concurrency, because, I mean, think of too, like you're operating millions of, maybe not millions, or even just tens, of components, and you need somebody to be there to make a decision who is to do what at what time. You don't want both kind of replicated cluster nodes to be doing things at the same time. So by that, then you do need some kind of leader to help. Now, good news is that if you're using Kubernetes, most likely too, you can just rely on like etcd, for example, that daemon already has the leader election algorithms already built in. But otherwise too, you can also use something external like Zookeeper. Apache Zookeeper will also help you. You can select some kind of leader election mechanism. So in order to use this, use a matter of more like configuration in this case. And then there's also in Kubernetes, there's this concept of stateful sets too. So as such, right, in big cluster environment, you have multiple nodes up and they kind of keep up and down. They each can be updated at any points in time individually. All of these things, if as developers, we need to worry about those, is a lot of extra thing that we don't want to deal with. So basically Kubernetes has stateful sets that you can configure to work. So then it makes sure that anytime there are any example, like any changes, it captures it, and it also keeps track of all the versioning, and also in the ordering of all of these parts that are coming up and down. All of these things too will help you to do that. Another capability within Kubernetes, if you want to kind of leverage on more on the persistent like volume level, they have features called persistent volumes too, that you can directly kind of manage all of your logical volumes, things like that too. I won't go into all the details in here, but just mention to you. And then there's also persistent volume set too that kind of works with it. And you can also request them. If you're using stateful sets, you can actually request persistent volumes to help you with that aspect. And then, as I mentioned earlier too, with the techniques in cookies, in Kubernetes too, it has a cookie affinity. It's called affinity session. So think of it like that, right? You are, let's just use an example that's not even like, lower level kind of computing terms, but let's say you are a customer, you call in for your phone service have issue, you call in a customer service, and that particular service representative is answering your call. And then you need to hang up to do something else and call back. And so it's kind of same kind of idea. You don't want a different representative to answer your call, and you have to repeat again who you are and register everything. So likewise, too, in Kubernetes, there's this cookies session affinity concept that you can, as long as you know, right, you have some requests going into Kubernetes, and it keeps track with this session affinity and knows that this is this request, this client request. Then with this session affinity capability, it can actually keep that valid, so then when you make the next request with this same client going in, it will be serviced by the same node, right, in your cluster, things like that. So that's in Kubernetes. And this is like, in a nutshell, how on the cloud native infrastructure can help you in terms of preserving data. Okay, and now let's kind of get into a bit on the programming side. So there's also design patterns that you can leverage too as developers. So this kind of gets a bit higher level into programming design. Let me make sure my time is good. Okay, so just want to quickly to bring up this particular design pattern is called SAGA pattern. So SAGA, how many of you have worked with or heard about it at all? Yeah, okay, so I have a few of you, so that's cool. Yeah, that's great. So SAGA, as the name implies, it's like a long history, right? If you kind of look at, we talk about, oh, it's a saga, it means something that lasts for a long time. So likewise too, right? You can have, like, again, using like an order entry shopping cart example, you could have, transaction that spans, hours too. Maybe you're ordering something and you need to check a couple things and you can't actually submit your order yet, that type of stuff. So having like a SAGA pattern will help too, this pattern. And the thing is too, is that it helps, especially when you're dealing with like multiple services, there are multiple transactions that are happening, but they all together form a single transaction, right, from a business perspective. So, and then in SAGA too, I mentioned about, well, actually did I mention, but there are two ways of, they call coordination SAGA. So anytime, as we know, right, doing concurrent processing, any kind of complicated scenario, you can't just let the process runs on its own. There's so many. So you do need some way of making sure they are all coordinated. So there are two ways, right, you can do is choreography. Choreography is essentially leverage on an event-driven approach. It's a driven kind of way of doing things. So very often too, maybe people are using Kafka, and then we're now trying to tell people use Pulsar to do it too. You can also do it like that way, or any kind of pops up kind of capability to help you with the messaging between different components. So that's choreography. And then the other way of doing SAGA will be orchestration. And that one will require like actually a coordinator, a broker in between to kind of help you to do things as a whole too. So then we'll take a quick look into that too. And also I wanted to point out with SAGA, there are no like rollbacks. So every time, right, when we do things, we like to think of sunny days. It always works. But guess what? In the real world, nothing works, most of the time. So yeah, so then what to do, right? If something goes wrong, especially a big transaction, you have things going on, you're checking somebody's credit rating, you're checking this and that. So if something goes wrong, you know that, oh, well, they order like 100 packages of toilet paper, but actually they don't have money in the bank. So you need to roll back, right? So, but in SAGA, it's not really rollback. You're doing what is called a compensation. So in other words, you actually will have to, in reality, you probably spend more time doing compensation. Because it's not exactly like a database rollback, right? It's more like, okay, I'm going to write, as long as I know I'm writing microservices to do some processing, I have to also write another corresponding microservice to actually do the compensation. So if something goes wrong, I know where to kind of go back to the original state, kind of like that. But it's still a forward thing in terms of computing, but you bring the state back to where it was before. It's a compensation. So, all right, let me make sure my time. Okay, so there's just a word to note is that for MicroProfile, right? So now we are all talking about open source. So MicroProfile has this feature called long-running action, LRA. It's actually quite a recent feature too. And that one actually, it employs like a SAGA interaction pattern. So right now, I guess we don't have any specific example to show that, but let me also then quickly show you just an idea of a choreography, SAGA pattern, just to kind of get you thinking. So in other words, I wanted to point out, you can actually implement maybe using an LRA pattern to do like shopping cart, right, order processing. So kind of looking at this example, we have order that are coming in. It can be like a Kafka, like I said, a broker that receives all the order, however it is. And then it goes into the order, the microservices order. So the order will then kind of start to do its work. And then there are events that are being generated. So this is SAGA pattern. So it's an event-driven way. So the thing is, with your order, you can kind of kick off, you basically can say, well, order gets generated. It first comes in, order is created, and then you need to kind of validate everything. If it's all good, that event gets generated, then basically the other microservices that are listening on that particular event, let's say order validated, then I know I have to go and do an inventory check. At the same time, I also want to do credit check, right? All these kind of other things can kind of branch off and do their own thing. But the whole thing too, they operate as a whole. So as you can see, it gets kind of quite complicated. And then if all goes well, inventory is all checked. I have the goods that are being ordered, and credit is checked. It's all good. This guy can pay the money, or this gal can pay the money. Then I'll say, awesome. Then basically too, I also have to update my order microservice and tell it, okay, now I'm good. Then I have to also update my order status. At the same time, then I know I can move on to the next stage, which is to process the payment, for example. And then if payment is all good, likewise, you're using event-driven way of doing things. If it's all good, it triggers. Maybe it will say, okay, payment is processed, all good. Now I can then go forward and send the data over to shipping, and the shipping processor will then do its thing. So you can get an idea of what this kind of processing can be quite complicated, and also you have to be very careful because it deals with payment and money, things like that. So it's actually a good way of kind of using this approach to do like a complicated type of scenario of designing your application using this SAGA pattern. Okay, so now with that, we'll get into the next part, which is a bit of a reactive, and I think Grace can kind of say something about that too. So
you might be wondering, with everything we've discussed, maybe you guys have, in fact, has anyone come across reactive before? Yeah, a few hands going up, great. So a lot of the words that we've been using throughout this presentation, you might realize are starting to come into play with things like the reactive methodology. So reactive, really, it's not a new term. It was just something that came into, there was a manifesto made about 2012, and really it's all about creating applications that mimic the same behaviors that we're trying to see within Cloud Native. So actually, this is another methodology that you can make use of if you're looking at creating effective Cloud Native applications. So the underlying principles really are that you have this really asynchronous, message-driven backbone of communication within your application. And what that enables is these additional characteristics and behaviors. So elasticity, resiliency, and responsiveness. And for those who are really paying attention, you might remember back to that original slide way back when we were looking at original definition that Netflix had, where you can see that actually these three characteristics map to those original characteristics of Cloud Native. You've got elasticity, that maps to that scalability characteristic they were after. You've got responsiveness, that maps to the performance that they were looking for. And then you've also got resiliency. So having resilient microservices, again, linking that back to those original factors. So really, all reactive is doing is trying to implement those same characteristics of Cloud Native. So this is another really useful methodology. And if you're interested in having a look, MicroProfile, again, open source, has some reactive APIs that you can make use of, like reactive streams, and you can also make use of the reactive stream specification, which is open source. So these are some really useful APIs that you can make use of if you're looking at Cloud Native. But I won't keep you any longer because we're all developers, and what we really want to see is code samples.
Yes.
So we're going to show you a quick demo now, just of some persistence with a Cloud Native application.
Yeah, that's right. So thank you, Grace. Okay, so let me kind of do this one thing. Let me see if I can. This is actually
it's difficult with a big screen.
Yeah, it's actually over there, right?
Have you found it? Can anyone see
the mouse, the cursor?
No mouse on the screen. You see it?
Oh, you see it now. Okay, thank you. I'm so sorry.
So the one that we're showing you now is based on OpenLiberty. So has anyone come across OpenLiberty before? One hand. Hi, Sasha. This makes sense. You work at IBM. OpenLiberty, for those of you who haven't heard, is essentially it's open source again. Very much involved with the community. We support APIs like MicroProfile and Jakarta EE. And essentially, has anyone heard of WebSphere? Maybe something, yeah, now we're getting some nods. So WebSphere is essentially, was our sort of main Java runtime. We wanted to try and make it a bit more lightweight, a bit more developer friendly. And so we created Liberty, and then we got on the open source bandwagon, and there is now OpenLiberty. So it is our open source cloud native Java runtime. And so, as I said, it supports MicroProfile, reactive, Jakarta EE, microservice testing, test containers, all that wonderful open source stuff. So if you're interested in running some applications, that's the one we're going to be using for this lab today. Right. And this is all based, this lab you can find on our website. And if anyone is interested in having a go at this lab or any of our other labs, we're actually running them on our booth downstairs. You can't miss it. It's big and blue. You'll see the IBM sign. Yeah. So if you're interested in having a go yourself, you can run these labs yourself in our cloud native environment.
Okay. Yep, that's right. So now, actually, because of how this screen is, but if you see we go. So if you look at the whole screen, you see a whole set of functionality you can try out. So not just for persistence, but we'd like to kind of share with you today some persistence example. We probably won't have time to get into stepping it through, but wanting to point out to you, right, we wanted to show like persistence. So let's say persisting data with MongoDB, right? That would be a good one to try. So as you can see, this is actually very, very helpful. And there's also a version of Skills Network, right, that you can do. Did you mention about the Skills Network lab, right? You can do interactive too. But here, we're just going to do it like on the command line. But we will quickly, let me see if I can get this going. So if you visit that, it's openliberty.io, and then /guides, and then go to persistence. You can find this. And all these links are at the towards the end of our slide deck. So you no need to copy if you miss it. So if you follow this, right? Yeah, can you see? Yeah. Okay, so if you kind of follow it, the nice thing about this too is that you can get started and it will tell you can clone. There's already GitHub repository ready too. So you can just copy this, for example, and I have already done it, so I won't repeat it here. But otherwise too, try it at the booth or try it at your leisure time, however way you want. So you can actually run this and actually testing. You can actually now, okay, there's another thing too with the Open Liberty guides are kind of nice. You can work on it, and for every exercise, there's a start directory and then also a finish directory. Finish directory will have all of your solutions. So if you're a little eager, like too eager to find out what happens, you can always go to finish directory and run the example and see what happens before you get into the start directory to try things out. So for today, just a quick demo, we'll go into the finish directory. Although I can't tell where I am right now. Am I in there? Kind of like, let me just kind of I am in the finish directory. Sorry. Okay, See, I've been doing like online presentations for so long. Now all of a sudden doing in person, I'm not used to it. So over here, I'm here. So you can just essentially run MVN. So they are all POM file. We're using that. And MVN space liberty, and then there are different directives you can use, right? So we can just do let's say do run. So run will essentially too, that it's like Spring, right? That I think a lot of you probably are working with Spring, as I'm guessing, right? Yeah. So likewise too, there's POM file already. You can run your Liberty applications right there using MVN, and then Liberty : and then run will bring up your application, and again. This just to, let me see, it says it's the default server is ready for a better planet, something like that. That means the server is up, so I can't remember exactly. So with that, then you should be able to then bring up your application. We were hoping to show a shopping cart example, but that one I think is undergoing some change, so we're not able to show that. But you can try that out, we'll have that fixed. So if you kind of run this, then it will bring up that particular web application. Now, there's also another exercise called persistence using JCache and Hazelcast. So that one, we're in the process of updating that, and that has a simple order processing or kind of order shopping cart example if you want to take a look at that. So this is kind of like a quick kind of a demo. I think we have like 5 minutes, right? So I will then quickly then also move over to show something with Pulsar. And I hope you find it useful now to know where to look for Open Liberty. So, and now let me go back. And so that one too, again, this is the link to how you get to all the set of exercises to do some hands-on. And so this is that. And if we kind of move on. So I want to spend just a few minutes talking about Apache Pulsar as well. So Apache Pulsar is such as a unified messaging platform. Unify, what does it mean? That means you can do messaging, you can do streaming. It supports pops up streaming and also like queuing, message queuing, and streams and all that kind of good stuff. The thing is that it's being designed actually at Yahoo. Yahoo started it, and then they donated it to Apache. And then in 2018 became a top-level project. So right now, Apache Pulsar, people have said that, it can replace like Kafka, for example. But I don't look at it that way. I think Apache Pulsar is designed with a different mindset in which it's actually enhancing what Kafka can do. Kafka, while it is very capable doing the PubSub, all the broker stuff, but with Pulsar is that it brings you to another level. It's designed already, taken into account that you're dealing with a cloud-native environment. As I mentioned too, right, we're talking about stateful microservices, right? Stateful kind of thing, you need to maintain them in all of your components that are scattered, in your cluster. They need to be going up and down. At any point in time, you need to rebalance, right? You have certain components running in some nodes and scatter everywhere, and then you take one down, take one up, you have to rebalance it. And Pulsar already has that built-in capability. So that's where I think it kind of shines, really. And so I'm highlighting in here too, basically, it's native from the start as a cloud-native provider. The highlight is that it's multi-tenancy. It's already kind of built in. Think of it as like an apartment building. You can have different tenants living in an apartment, and they each have their own control of all of this stuff. So essentially, that's how Apache Pulsar has been built for. Also, too, another great thing about it is for geo-replication. Like you can have a huge data center that are running different copies of your application in different regions, like in North America, South America, EMEA, like Europe and Asia. But then each one of them, they could have like different rules to their data too. So that's the nice thing is at Pulsar too, you can configure. For example, Europe has GDPR, and so there's certain data you want to apply those rules, right, kind of easily, and you still want to be able to replicate it correctly to all your data centers running everywhere. So that's the nice thing is that as developers, you don't need to write specific functions to deal with all those things. It's kind of pain in the neck. So you can actually rely on Pulsar, that Pulsar has the configuration capability. You can configure certain rules. How do you want to replicate, apply all those rules? So it's already there. So I just want to highlight that. And also, too, is that why is it like so kind of more powerful, so to speak, is because they're designed to, they separate out the compute and the data storage side. So in other words, like Pulsar itself is a PubSub kind of messaging broker. It does all the stuff very well. The source, different source, you can have IoT data coming in from your devices, collect them into Pulsar, and then it kind of broadcasts, or not broadcasts, but kind of through the broker. Whoever subscribes to it can receive the messages, all those things. The thing is that you need to save all those data, right? There are topics that you label all of your messages. You need to save them. They keep track of it, so if the broker dies, it knows to come back to it, that type of stuff. So what it does is that it separates out all of the data into separate storage. So then it's separation of concern. It makes it to be extra scalable too. Because now if you think of it, you have certain nodes going up and down, all of these things. You basically, in this case, we're using Apache Bookkeeper. It's another open source project that helps with the journaling, the ledger, all of these things for all of your data. So then the Pulsar itself can focus on all the compute, and then while it delegates over to Apache Zookeeper to help you with all of the data. So essentially what it is. So, okay, so now then how do you kind of use it, right? So that's what I'm kind of going to, and now, do we want to talk? Okay, all right, okay, 5 minutes, okay, I'm sorry, okay, thank you. I talked too much. Okay, well, the thing is too, I have given you this link too, you can actually sign up for the Astra Cloud. So that one you can get a free account, and it's actually got free credit too. It's pretty easy if you want to do something kind of basic. Again, the $25 credit to start with is actually sufficient. So, okay, and now we get into some resources and link, and then Grace can tell you some more about it.
Because we haven't given you enough homework already.
We've
got a whole 3 pages of links.
Yeah.
So seriously, if you guys are interested in finding out a bit more about, we've sort of given you this really, I'm going to use the word rushed, tour of all of this environment. So if you want to look into these in a bit more detail, then do visit these individual links. So we've got some links there to our code samples. We wish we could have shown you a bit more of those, but check them out for yourself or come visit the booth. We've also got some links to things like MicroProfile LRA if you're interested in that, SAGA designs, and the individual open source projects that we've mentioned. Don't panic, I'm going to change the slide now, but we will be sharing them. Next slide.
Yeah.
So we've also got other topics like our IBM developer resources. Do check those out, and other ones like the 12-factor app methodology I mentioned, and there's also the Cloud Native Computing Foundation, as the name suggests. They're pretty expert in all things cloud native. There's also some additional resources. Sorry, I didn't give you warning for that one. Next slide. Again, we'll be sharing these. So if you want to check out things like Zookeeper, if you want to check out DataStax, Pulsar, check out the links that we've got here. I'm switching in 3, 2... Okay, and if you're interested in maybe running some managed Cassandra, you can check out our services on IBM Cloud as well. Now, obviously, this is only the beginning of your conference journey, so I hope you're not already burnt out with all the information we've chucked at you. But if you're not, then do check out these additional sessions that we've got. Again, more open source, focused on some of those open source technologies we've been talking about, like MicroProfile and Party. So check out more of our sessions later on this week, well, a couple of days.
Yeah. Okay. Yeah, and then we also have some community information. If you're kind of into signing up for some online tutorials, we actually have IBM too, has the Expert TV. Also, different meetup.com have also IBM developer free tutorials. And then on DataStax, we also have workshops too there on Cassandra, and now we're trying to add in Pulsar as well. So YouTube channel, you can visit that, you can watch it anytime. Also, I'd like to recommend you, right now we're still online, all of the meetups at Chicago Java Users Group. So you're all welcome to join us too. We raffle off JetBrains license at every meetup too. So that will be an incentive for you to join. And then also, I have a Twitch sessions that I run every Wednesday afternoon about 2 p.m. So if you want to join me, I'm actually today I may still kind of pop in a little bit, maybe just show around Devnexus and talk about things. So otherwise, I'm talking about different things too. Okay, and then a bit of more Pulsar if you're interested in learning more too. We're starting up some meetup groups and also a neighborhood we call. It's really open source community for the community to get together. Okay. And then with that, I think we want to thank you. Wow.
That was
yeah, thank you.